All right, so tonight's lesson is actually going to be possibly the shortest in terms of length. It's on a concept called perfect square trinomials. What's great about perfect square trinomials is actually if you use any of your other methods in relation to factoring trinomials, you can kind of get away with not knowing how to factor a perfect square trinomial. But because perfect square trinomials are important later on in our study of quadratics, I'm going to cover them anyway. So perfect square trinomials work like this. You'll remember from our special products lessons that when we had an x plus 5 squared, like we do here, and we were to expand that, we'd actually wind up expanding it by taking that first term squared, that second term, and squaring it. And by taking these two terms together, multiplying them together, and then multiplying by 2, we would actually be able to expand it quickly, or at least faster than we would with using FOIL. Okay? But again, if you really need it, x plus 5 bracket x plus 5 is the same thing as x plus 5 all squared, and you can do FOIL, and you would actually eventually get that as well. Okay? It's just a shortcut that we picked up along the way. This is what we call a perfect square trinomial because it's the result of squaring a binomial. So you'll notice that this term is a perfect square, and this term is a perfect square, and this is exactly twice the square root of the first term and the last term. What's in the highlighted box is extremely important to remember. So to check to see if a trinomial is a perfect square trinomial, you need to make sure that both the first term and the last terms are perfect squares. But you also have to make sure, and this is really important, that half the middle term's coefficient squared would give you the last term. Okay? So half of this is 5x, and its coefficient is just 5, and its coefficient of 5 squared would give you the 25. That's essentially how you would check that that middle term was constructed from both the first term and the last term. Let's do a few examples, and maybe this will make a bit of sense. So with example number 1a, we see that that's a trinomial. Now, easily enough, we'd be able to factor it using our simple trinomials ability. Our saying it has to add to 12, and it has to multiply to 36. And what are the two numbers we're thinking about, okay? But the first thing we actually want to do is verify that it is indeed a perfect square trinomial, okay? How do we do that? Well, let's look at the last term. It's 36. And let's look at the first term. It's x squared. So the last term's square root would be 6. And the first term's square root would be x. And x times 6 times 2 would give you the middle term, which is 12x. Okay, so hopefully that check that I've written there in blue makes a lot of sense. I'm just going to erase it so that we can get our factoring done. So back to factoring, the two numbers that you're probably thinking of are 6 and 6. That's what makes this a perfect square trinomial. So if you're factoring this as a trinomial, you would probably think, well, it's 6 and 6. There you go. I mean, the one last step is really to simplify this further by saying, well, it's x plus 6 squared. Okay, and I'd kind of like to see that. I mean, x plus 6 times x plus 6 isn't really fully factored. X plus 6 all squared is the best way to fully factor it. So with example B, it's really no different than the first one, except we've got a negative bouncing around here. Okay, so if we think about it, let's verify that this is a perfect square trinomial first. Look at the first term, look at the last term. What's the square root of the first term? It's x. What's the square root of the last term? It's 4. And what's 2 times x times 4? It's 8x. And that matches with that term in the middle. Well, I'm sure you're wondering, what do we do with this minus here? What about that? Well, that's where the minus actually just pops into the middle. X minus 4 all squared. Okay, so that's a quick and easy way to do that factoring. Again, you could use factoring a simple trinomial. You could use the adds 2 multiplies 2. The two numbers you're looking for are minus 4 and minus 4. That's why it's a perfect square trinomial. Finally, with example C, we can see that we have a perfect square trinomial, and all of those numbers are actually quite large. So I dare you, in fact I don't dare you, but you would probably not want to have to do factoring by decomposition for example C. That would be very difficult, right? You'd be looking for something that multiplies 49 times 4 and adds to 28. We're talking about huge numbers here. It'd be pretty difficult to manage. So let's try and verify that this is a perfect square trinomial, and then just factor it, okay? So is the first term a perfect square? Well, yes it is. 49a squared. What's the square root of it? It's 7a. What's the square root of this last term? Well, that's 2b. And 2 times 7a times 2b would be our middle term. So 2 times 7 is 14, times 2 is 28, a, Does that match that middle term? You bet it does. Okay, so we verified that this is a perfect square trinomial. Now we have to just factor it. To factor it again, all we're going to do is need to take the square root of the first the square root of the last, put them in brackets, square them because it's a perfect square, trinomial, and take that sign. And that's it, that's all. So it's a neat, quick shortcut, and in some cases, it's definitely going to help you. I mean, yes, we could factor question C like a complex trinomial by doing decomposition, but it'd probably take you a while. You're going to be there a long time. So one last example for you to consider this evening is example number 2, where I'm asking you to find the values of k so that x squared plus kx plus 81 is a perfect square. Well, k is the value that's right here in the middle. What number could we be looking for that would sort of satisfy this? So again, the exact same process of verification as I was doing in example number 1 is this. What's the square root of that? It's x. What's the square root of that? It's 9. So what is 2 times x times 9? That would be your middle number. That would be your middle term. 2 times x is 2x times 9 is 18x. So k must be 18. That's one possibility. K could also be actually technically negative 18 because that could also be a minus, right? Like if k was a negative, we'd be adding a negative 18. So k could also be a negative 18. So an interesting concept nonetheless. Really, really quick lesson, I hope. Not much to go over. We'll talk about this more in detail in class tomorrow.